Good morning. This is Madhu. Today we are going to discuss about light. We have already known that light is one form of energy. It travels through any medium or even though it travels through the vacuum also. So before we discussing refraction of the light, we recall the knowledge which you have already learned in the previous class. That is, first, medium. What is meant by medium? The substance or the material in which light traveling is known as medium. So medium can be divided into three types as per the nature of the material or substances. So mediums can be divided into three types. One is transparent medium, second one is semi-transparent medium, third one is opaque medium. So what is meant by transparent medium? Any material is said to be transparent medium in which the light energy completely passing through it. Those material is called transparent medium. For example, air is a transparent medium. Water is also transparent medium. Colorless plastic sheets or colorless glass sheets are also called as transparent medium. Second one, semi-transparent medium. What is meant by semi-transparent medium? The material in which light energy partially passing through it. Those material is called semi-transparent medium. For example, thin silk cloths are treated as a semi-transparent medium, and also oil paper is also treated as a semi-transparent medium. Next, opaque medium. What is meant by opaque medium? The material in which light cannot pass through it. Those medium is called opaque medium. For example, wall is treated as a opaque medium. Blackboard is treated as a opaque medium. Wood is treated as a opaque medium. The material in which light cannot pass through it, those medium is called, those material is called opaque medium. And also recall the properties of the light energy. We know that light is a one form of energy. It has so many properties such as reflection, refraction, total internal reflection, dispersion of the light, and scattering of the light, and interference and diffraction. Reflection. What is meant by the reflection? I think all of you have learned in your previous class, that is reflection. What is meant by reflection? The light energy, the light rays or light beams which come from any light source incident on the surface of the opaque substance, at the time those light ray reverses or those light ray bounce back. Those phenomena is called reflection. Here we have to remind one important thing, that is the reflection of the light occurred only when the light rays incident on the surface of the opaque substance. Again, just recall the reflection of the light concept. For example, this is treated as a one opaque substance surface. Opaque substance surface. This is treated as a one light source. Any light ray which comes from this light source incident on one point of the opaque substance surface, where this light ray incidents, those point is called incident point or point of incidence. So according to properties of the reflection, this light ray bounce back or reverses. This is called reflection of light. We have some properties for reflection of the light. For example, if you draw one normal to this point of incidence, this is normal. Normal means it makes a right angle with the opaque substance surface. That's why it is called normal. This is called incident ray. Incident ray. This is called reflected ray. Reflected ray. Here, two angles are formed. The angle between incident ray and normal is called angle of incidence, which is denoted by the letter small I. And also, one more angle is formed between normal and reflected ray is called angle of reflection. Angle of reflection. According to the property of reflection, any light ray which comes from any light source incident on any one point of the opaque substance surface, those light ray reverses or those light ray bounce back. This phenomenon is known as reflection of the light. Here two angles are formed. If we draw the one normal from the point of incidence, at that time two angles are formed. One angle is angle of incidence. What is called the angle of incidence? The angle between incident ray and normal is called angle of incidence, and also the angle between normal and reflected ray is called angle of reflection. Once again, I recall the properties of the reflection. What are the properties of the reflection? We have three properties. One is, according to reflection, angle of incidence is equals to the angle of reflection. Angle of incidence is equals to the angle of reflection. For example, the angle of incidence value is equals to 40 degrees. The angle of reflection is also 40 degrees. The angle of reflection is 60 degrees. The angle of reflection is also 60 degrees. So, angle of incidence is equals to the angle of reflection. Next, second point, incident ray and reflected ray existing on both sides of the normal. Both sides of the normal. You have to remember this thing. Incident ray and reflected ray existing on both sides of the normal. Next, third point is incident ray, normal and reflected ray lying on the same plane. Lying on the same plane. So these are the properties of the reflection. So first property is angle of incidence is equals to the angle of reflection. Second property is incident ray and reflected ray existing on both sides of the normal. And third point is incident ray, normal and reflected ray lying on the same plane. Here we get one out why the angle of incidence must be equals to the angle of reflection when any light ray incident on the opaque substance surface. So, because of this concept explained by the scientist Fermat, he was one of the famous mathematician and philosopher. He derived that any light ray which comes from any light source chosen by itself to take least time taken path to travel. Any light ray which comes from any light source chosen by itself to take least time taken path, so that this incident ray must be passing through in this direction. This is called Fermat rule. Fermat rule. According to this rule, any light ray which incident on the opaque substance surface, at the time reflection is occurred, then angle of incidence must be equals to the angle of reflection. Okay, now we are going to discuss about the refraction of the light. So now we are going to discuss about refraction of light. In your regular life, we have observed so many things. That is, when we place any pencil or any metallic rod in the glass of water, other than what happened, it seems like a bend. It seems like a bending at the interface of the two mediums. And also, if you place any lime fruit in the glass of water, it seems bigger than its original size. And also, if you write any letters on the chart and put one glass slab on the chart, other than what happened, those letters which are written on the chart looks like a bigger and comes like a upwards direction. So these are all due to refraction phenomena. So refraction is also one property of the light. Here we have to remind one thing. Reflection is occurred only on the opaque substance surfaces, but refraction is occurred only in the transparent substances. We have already know that transparent substances or transparent medium, the material in which the light energy completely passing through them, those material is known as transparent material. For example, if you take one glass of water, if you place any metallic rod or glass rod in the slant direction, this is called the surface which divides. This is air, this is water. Both are transparent mediums. The surface which divides both mediums is known as interface. The original position of the rod is like this, but it seems like this because it seems bending at the interface of two mediums. Why this happened? Why this rod seems like a bending in the water? Because of refraction. Refraction is one property of the light. It occurs only in the transparent mediums. Here, two mediums. One is air and another one is water. Both are the transparent mediums. Before we are explaining about refraction, we have to know what is meant by rarer medium and what is meant by denser medium. So, rarer medium is also transparent medium, denser medium is also transparent medium. Rarer medium means any transparent medium is said to be rarer medium in which the velocity of the light is more. The velocity of the light is more. Those medium is called rarer medium. Next, denser medium. What is meant by denser medium? Any transparent medium is said to be denser medium in which the velocity of the light is less. Those medium is treated as a denser medium. Here, in this example, air is a transparent medium and also water is also transparent medium. But the velocity of the light in the air is more than the velocity of the light in the water, so that air treated as a rarer medium and water treated as a denser medium. That's why the metallic rod or glass rod which is placed in slight direction in this glass of water it seems like a bend at the interface of the two mediums. Here, interface means the surface which divides both mediums is known as interface. So that here it seems bent at the interface of two media because of refraction. Now we are going to discuss about refraction. What is meant by refraction? Refraction is a property of the light. When any light ray which comes from any light source travels one transparent medium to another transparent medium, those light ray changes its direction at the interface of two media because of the velocity of the light change. This is called the refraction. Again, any light ray which travels from one transparent medium to another transparent medium, those light ray changes the direction at the interface of two media because of the velocity of those light ray changed. This phenomena is known as refraction of the light. Refraction of the light also can be defined in other words. For example, this is treated as a denser medium. This painted one is treated as a denser medium. This is treated as a rarer medium. For example, this is one light source. One light ray incident at any one point of the interface of a two media. Immediately we have to draw one normal at the incidence point and also draw the original direction of the incident light ray by using dotted lines. We have already explained that any light ray which travels from one transparent medium to another transparent medium, this light ray changes its direction. So it bends nearer to the normal. Nearer to the normal. Why it bends nearer to the normal? According to definition of the refraction, any light ray which travels from rarer medium to denser medium, the corresponding refracted ray moves nearer to the normal. That is fundamental. Any light ray which travels from rarer medium to denser medium, the corresponding refracted ray moves nearer to the normal. Here, one angle is formed. Two angles are formed. One angle is the angle between normal and incident ray is called angle of incidence. Angle of incidence. And one more angle is formed. The angle between refracted ray and normal is called angle of refraction. By observing this diagram, it is very clear that when any light ray which travels from rarer medium to denser medium, the corresponding refracted ray moves nearer to the normal, so that the value of the refraction is less than the value of the angle of incidence. Angle of incidence. It is very clear that by observing this diagram. And also sometimes one light ray travels from denser medium to rarer medium. Denser medium to rarer medium. For example, this is treated as a one light source. One light ray travels from this medium. The painted one is treated as a denser medium. This is rarer medium. One light ray travels from denser medium to rarer medium. It incidents at one point of the interface of two medias. Immediately we have to draw one normal at this point. Again you draw the original direction of the light ray in the dotted form when there is no refraction occurring. Okay? travels from rarer medium to denser medium. After refraction, the corresponding refracted ray moves nearer to the normal. Rarer to denser. Here, case is reverse. The light ray travels from denser to rarer. At that time, the corresponding refracted ray moves away to the normal. So, how can you find that it moves away to the normal, or how can you find that the corresponding refracted ray draw in this place or in this place? Because the original direction of the light ray is in the dotted form. If we draw in this space, it comes nearer to the normal, so that we draw in this direction. At that time, we can say that the corresponding refracted ray moves away to the normal. Here also, two angles is formed. One angle is the angle between incident ray and normal. Those angle is called incident angle. And also, one angle is formed between normal and refracted ray. Those angle is called angle of refraction. By observing this diagram, it is very clear that when any light ray travels from denser to rarer, at that time the corresponding refracted ray moves away to the normal, so that the angle of incidence is greater than angle of refraction. So, we can explain refraction in three ways. First, what is meant by refraction? Refraction is the property of the light ray. When any light ray travels from one transparent medium to another transparent medium, those light ray changes its direction due to the change of velocities occurred. That is fundamental definition. So, when we take two transparent mediums, at that time one is treated as a rarer medium and another one is treated as a denser medium. What is meant by rarer medium? The medium in which the velocity of the light ray is more, those medium is treated as a rarer medium. What is meant by denser medium? The medium in which the velocity of the light is less, those medium is also called denser medium. Due to the rarer medium and denser medium classification, we can define the refraction of the light in two ways. One is any light ray which travels from rarer to denser, the corresponding refracted ray moves nearer to the normal. In the same manner, any light ray which moves from denser to rarer, the corresponding refracted ray moves away to the normal. In the first case, the angle of refraction is less than the angle of incidence. In the second case, the angle of incidence is greater than the angle of refraction. And also, we have to remind one important thing, that is, any light ray which travels along the direction of the normal from one transparent medium to another transparent medium. At that time, what happened? It means any light ray from any light source incident on any one point of the interface of two media perpendicularly. At that time, what happened? The corresponding refracted ray is also travels in the same direction. You have to remember this thing, very important. So, any light ray travels from one transparent medium to another transparent medium, incident at any one point of the interface of two media, vertically or perpendicularly, or moves along the direction of the normal. At that time, what happened? The corresponding refracted ray doesn't deviate its direction. Okay? So, this is the brief introduction about refraction. Okay? Now, we are going to discuss about refractive index. What is meant by refractive index? Every transparent medium has this value. The ratio between velocity of the light in the vacuum to the velocity of the light in the medium what we have taken in this particular context is known as refractive index of those media. So it is a ratio, so that it has no dimensions. The ratio between velocity of the light in the vacuum to the velocity of the medium what we have taken in this particular context is known as refractive index of those medium, which is denoted by the letter N. So N is equals to a refractive index, C is equals to velocity of the light in the vacuum. It is a constant value, 3 into 10 power 8 meters per second, and V is equals to velocity of the light in the medium. What we have taken in this particular context. So we said that refractive index is a ratio between velocity of the light in the vacuum to the velocity of the light in the particular medium. So N is equals to C by V. Here numerator in this fraction, numerator always remains constant, but the value of the denominator changes if we change the material. For example, in any fraction, the value of the numerator more than the value of the denominator, other than the value of the N is more. If the refractive index of the any material is more, any transparent medium is more, those medium is treated as a denser medium, because here the value, the fraction value, it is constant. If the value of the velocity of the light is more, then this value becomes, the value of this fraction becomes less, so that if the value of the N is more, those medium, for example, if we compare the refractive index of any two transparent mediums, in which one transparent medium has more refractive index value and another transparent medium has less refractive index value, at that time we can conclude those mediums, we can classify those mediums rarer and denser very easy, because if any medium which contains more refractive index value, those medium is treated as a denser medium with respect to other. If any medium contains less refractive index value with respect to other medium, at that time those medium is treated as a rarer medium, because N is equals to C by V. In this fraction, the numerator value always remains constant. If the denominator value increases, the value of the fraction decreases. If the denominator value decreases, the value of the numerator, the value of this fraction increases. So by observing the value of the refractive indices of any two mediums, we can conclude which medium is rarer and which medium is denser by using these two values. Here we have some values, some refractive indices values of the materials which are available in our nature. For example, air has 1.003, means nearly 1. Ice cubes has 1.31. Water has 1.33. So by observing these values, for example, we can explain the phenomena of refraction by using air and water mediums. At that time, air is treated as a rarer medium and water is treated as a denser medium, because air has less refractive index value with respect to water. And also fused quartz, it is a material which is made from glass. So the value of those material, the value of the refractive index is 1.46. Turpentine, I think all of you know that, which is whenever we painting by using this oil, we can mix paints. So 1.47. Crown glass which is used at the windows. So 1.52. Benzene, it is a hydrocarbon. 1.50. Rock salt we are using in our in the making of foods in our home, that is rock salt. 1.54. Ruby, it is one aesthetic material which is used in the rings and ornaments. So ruby, it has 1.71. And diamond has a 2.42. So in our nature, diamond has highest refractive indices value. Index value. So if you take any two materials while explaining the phenomena of refraction, by observing these two values, by observing the refractive index of those values, we can classify those two transparent mediums, which one is rarer and which one is denser. Next we are going to discuss about relative refractive index. Relative refractive index is nothing but comparison the values of refractive index values of two mediums. So the relative refractive index can be defined as the refractive index of one medium or first medium with respect to the second medium is defined as the ratio between the velocity of the light in the second medium to the velocity of the light in the first medium. It can be algebraically expressed as the refractive index of first medium is m. The refractive index of second medium is n. The velocity of the light in the first medium is equals to mu. The velocity of the light in the second medium is equals to v2. So we can find the refractive index of the first medium with respect to second medium. Also we can find the relative refractive index of the second medium with respect to the first medium. How? So the refractive index of first medium with respect to second medium can be write as n1 n1. The refractive index of the first medium with respect to second medium is known as relative refractive index of the first medium with respect to second medium. It can be write as n12 is equals to n1 by n2. Okay. According to the definition of the refractive index, what is meant by refractive index? The ratio between the velocity of the light in the vacuum to the velocity of the light in that particular medium what we have taken in this particular notation. So n1 means refractive index of the first medium. It can be write as c by v1 because the velocity of the light in the first medium is v1, it is given 4 divided by into c by v2. C by v2. C by v1 into v2 by c. C gets cancelled here. So v2 by v1. So n12 is equals to n1 by n2 is equals to v2 by v1. So N12, what is meant by N12? The refractive index of the first medium with respect to the second medium. The refractive index of the first medium with respect to the second medium is equals to velocity of the light in the second medium to the velocity of the light first medium. So it has no units because in the numerator and the denominator both are the same dimensions or same units, so that it has no units. So N12 is called relative refractive index of the first medium with respect to the second medium. And also we can find the relative refractive index of the relative refractive index of second medium with respect to first medium is equals to N21. N21. So N21 can you write as N2 by N1. What is the N2 value? C by V2. What is the N1 value? C by V1. C by V2 into V1 by C. C is cancelled. So N21 is equals to N2 by N1, that is equals to V1 by V2. So this is the relative refractive index of the second medium with respect to the first medium. So don't confuse with N12 and N21. N12 means relative refractive index of the first medium with respect to the second medium. It can be written as N1 by N2, that is equals to V2 by V1. And also N21 is called as relative refractive index of the second medium with respect to first medium. We can be write as N2 by N1, that is equals to V1 by V2. So relative refractive index means it is a comparison between two refractive indices values of the two transparent mediums. For example, we take two transparent mediums, both are having different refractive index values. When we compare those two values, that is called relative refractive index. The refractive index of first medium with respect to the second medium is defined as the ratio between velocity of the light in the second medium to the velocity of the light in the first medium. We are going to explain one lab activity. By doing this lab activity, we can find the relationship between angle of incidence and angle of refraction when any light ray moves from one transparent medium to another transparent medium or rarer medium to denser medium. To do this lab activity, we require some material, that is a wooden flat, white chalk or white drawing board, protractor, semi-circular glass and small black painted plank and one laser light. So what is the procedure? How to do this activity? First of all, we take one wooden flank. Those flank is covered with a white drawing sheet or white drawing chart by using clamps. So those wooden flank is covered with white drawing chart or white drawing sheet. At the center of the drawing chart, we can draw the one horizontal line and one vertical line in such a manner both lines are perpendicular to each other. Those two lines intersect at one point. We name those point of intersection as O. Okay. Next, by using protractor, we mark the all angles from 0 to 90 degrees, 0 to 90 degrees, 0 to 90 degrees, 0 to 90 degrees on both sides of the vertical line NA. By using protractor, we mark the angles from 0 to 90 on both sides of the vertical line MN. Here the horizontal line treated as a interface of two medias. Now we are taking one semicircular glass. So semicircular glass is like this. The shape of the semicircular glass is like this. So we are taking one semicircular glass and put the semicircular glass in such a manner the base of the semicircular glass coincides with the horizontal line So we put the semicircular glass is like this. Okay. Now we are taking one laser light. What is the laser light? It emits a sharp light ray. That's why we are taking one laser light. First, we put those laser light at 0 degrees. We put those laser light at 0 degrees and emits one light ray in such a manner which passes along the MN, and it must to passes through the point of intersection O. Then observe the corresponding refracted light ray of those light ray which passes along this line. We have already known that any light ray which emits from any light source incident on any one point of the interface of two transparent media in the perpendicular direction, the corresponding refracted ray doesn't deviate its direction. So here also the corresponding refracted ray moves in the same direction. There is no deviation. If we are not able to see the refracted ray at the time, we put one black colored wooden flank at the edge of the glass tub to get the direction of the refracted ray. That is the use of black painted wooden flank. Okay. So it is very clear that any light ray which passes one transparent medium to another transparent medium, those light ray incident at any one point of the interface in the vertical direction or perpendicular direction, at that time the corresponding refracted ray doesn't deviate its direction. Here you get one doubt. Here what are the transparent mediums? Here there is no. Here only white board is there, white chalk is there. That's why it is treated as a A. Here we place one semicircular glass. Here the light ray passing through the semicircular glass, so that it is another transparent medium. This is one medium and this is another transparent medium. So we have already known that the refractive index of the glass is more than the refractive index of the air. Air is nearer to 1. The refractive index value of the air is 1. The refractive index of the glass is more than 1. That's why here A is treated as a rarer medium and this semicircular glass is treated as a denser medium. Okay, now we put this laser light at 10 degrees incidence angle. 10 degrees incidence angle, and it is very important these light ray must pass through the point of intersection O, and observe the corresponding refracted ray at this side. If we are able to see the corresponding refracted ray very clearly, no problem. And if we cannot see those corresponding refracted ray, at that time we place one black painted wooden flank so that it gives the direction of the corresponding refracted ray. So it is very clear that those value must be less than 10. How can you say that those value must be less than 10? We have already known that according to the definition of the refraction, Any light ray which passes from rarer to denser, the corresponding refracted ray moves nearer to the normal, so that here incident angle is 10 degrees. So it is very clear that the refracted angle must be less than 10. Tabulate these values in the given tabular column. I is equals to 10 degrees, R is equals to less than 10 degrees, sin I value and sin R value, and find the ratio of the sin I and sin R, and those values is equals to treated as an ES1, first SN1. And again do this activity, for 15 degrees, 20 degrees, 30 degrees, 40 degrees, 45 degrees, like this, and also find the corresponding refracted ray angles and tabulate all those values in the given tabular column. We can find every time the ratio of these two values, sin A by sin R, for every time we get constant value or same value. So this is the relationship between angle of incidence and angle of refraction when any light ray passes from one transparent medium to another transparent medium. This value gives the refractive index of the material what we have used in this particular test. Here what we are using semicircular glass. So this value gives the refractive index of the semicircular glass. So here for every incidence angle, we get smaller refraction angle. Because here the light ray moves from rarer medium. So rarer medium is A, rarer medium to denser medium. According to the definition of the refraction, any light ray which moves from rarer to denser, the corresponding refracted ray moves nearer to the normal. So by doing this activity, we concluded that any light ray which moves from rarer to denser, the corresponding refracted ray moves nearer to the normal, and also for every angle of incidence, the sin I by sin R remains constant. Those values gives the refractive index of the material which is used in this particular context. So sin I by sin R is equals to constant. So again we are explaining one more lab activity. In this lab activity also, to find the relationship between angle of incidence and angle of refraction. But here when the light ray travels from denser to rarer. In the previous case we have already explained when any light ray travels from rarer to denser, but in this lab activity we are explaining when the light ray moves from denser to rarer. To show the relationship between angle of incidence and angle of refraction when any light ray moves from denser to rarer, for that we require some material, that is circular metallic disc, straws, beaker, water, etc. So what is the procedure? How to do this lab activity? First of all, we take one circular metallic disc. So it is made from a thin metallic sheet, circular metallic disc, and draw one horizontal line at its center and vertical line. Those two lines must be perpendicular to each other. The point of intersection is noted as a O. And arrange two plastic straws. At its center in such a manner they rotate easily about its center. By using protractor, by using protractor, we mark the angles from 0 to 90. 0 to 90 from on both sides of the NN line or both sides of the vertical line. So it is you have to make some arrangement. First we take one circular metallic disc and draw two lines vertically and horizontally. Those two lines must be perpendicular to each other, and the point of intersection of those two lines is called O, and we arrange two straws at its center in such a manner they rotate very easily above its center. And by using protractor, we mark the angles along the edges of the circular metallic disc from 0 to 90 on both sides of the line NN. Okay, now we put one straw at 10 degrees angle. One straw at 10 degrees angle. Whatever it may be. At 10 degrees angle. And take this circular metallic disc and immerse it in such a manner the MM line is coincides with the surface of the water in the beaker. So here the surface of the water is treated as an interface of two mediums. Here this medium is air, this medium is water. So the straw which puts at 10 degrees angle must be immersed in the water. Must be immersed in the water. And again you arrange the second straw which is in the air in such a way these both straws are lying in the same straight line. By observing in the vertical direction, we arrange this straw which is outside of the water in such a way this straw must be lying in the same straight line. Remove this circular metallic disc and find the angles. We have already known that first straw put at 10 degrees angle and find the straw which is outside of the water and find the angle between the straw and this normal. It must be greater than 10 degrees. How can you say that? Because here light passes from water to air. The refractive index of the water is 1.33 nearly. The refractive index of the air is 1.003. So the refractive index of the water value is more than the refractive index of the air. So that water is treated as a denser medium and air is treated as a rarer medium. So that this straw, the angle between the straw which is outside of the water and the normal is more than 10 degrees. Tabulate all these values in the given tabular column. 10 degrees, it must be greater than 10 degrees, and sin A, sin R, it gives one constant. Do this same activity for 15 for 20 degrees, for 30 degrees, like this, and find the refraction, angle of refraction by using the straw which is outside of the straw, and tabulate all these values in the tabular column. For every angle of incidence, the sin A by sin R value becomes constant. But don't do this activity more than 48 degrees, more than 45 or 48 degrees, because the critical angle of the water, it explains later, when we put the straw which is in the water more than 48 degrees, at that time the straw not appears when we see outside of the water, because total internal reflection is occurred. It explains in the next class. So this lab activity must do where the straw which is immersed in the water less than 48 degrees or 45 degrees. Don't put more than 45 or 48 degrees. So for every angle of incidence, we get sin I by sin R value remains constant even though the light ray passing from denser medium to rarer medium. But here we get one observation: for every angle of incidence, we get one angle of refraction. Those value must be greater than the angle of incidence. Those value must be greater than the angle of incidence. Why? Because here the light ray travels from denser medium to rarer medium. The light ray travels from denser medium to rarer medium. For example, this light ray is treated as an incident ray. This straw is treated as an incident light ray, and this straw is treated as a refracted ray. It is very clear that this angle of incidence is more than the angle of refraction. According to the definition of the refraction, any light ray which passes from rarer to denser, the corresponding refracted ray moves away to the normal. So that for every angle of incidence, we get the angle of refraction must be bigger value. So by doing this lab activity, when any light ray moves from the previous lab activity, we explained the relationship between angle of incidence and the angle of refraction. Sin R by sin R remains constant when light ray travels from rarer to denser. In that case, the angle of incidence is less than the angle of incidence is more than the angle of refraction. But in this case, here light ray travels from denser to rarer, but angle of incidence is less than the angle of refraction because the refracted ray moves away to the normal. So by doing these two lab activities, we can find that sin I by sin R remains constant when any light ray moves one transparent medium to another transparent medium, either rarer to denser or denser to rarer.